right, so I didn't put a blank up there for ISN page because I know it looks like you have a lot of space, but when I actually make it, I have like no space up there, so we're just going to have to write it in. I think we can handle that. I believe it was 152, but you'll have to correct me if I'm wrong because I already forgot. And because I was trying, at first everything was too small, like it always is, and I print it out and I write on it, I'm like, dang, this is way too small. So what I ended up leaving off after I put on all this stuff that I wanted to make sure you had was the actual definition. And I was going to have you write it like in some of the blank space, but it's kind of long. So I just want to tell you what it is, and then we'll write it on the homework part today because there's a place for it. And then I will just give you something that has all the official definitions of all of them together. And then because the wording is important for that kind of stuff. So the definition of a parabola is a parabola is a locus of points. Okay, so what's the locus mean? A set. Okay, so a locus of all points in a plane, so it's two-dimensional, that are equidistant from a fixed line. What's the fixed line that they're all the same distance from? The directrix. Have y'all heard that word before? Yeah, the answer is yes. And a fixed point not on the line called the focus. And the focus is always inside the curve. Okay, so here, this is a very good little summation here of parabolas, right? They can open either up or down or left or right. Right? These are functions, these are not. Yes? We all agree with that? Directrix, focus. So here's the vertex. Do you see how the vertex here is the same distance from the focus as it is from the directrix, right? These dotted lines are not the axes. They could be, that is a possibility, but that's not what this is right here. This is the axis of symmetry, okay, which means I could reflect it in this line and it's the same. And then this is the directrix, and we'll look a little bit more at how all that stuff works in just a minute. This is your standard form equation. If x is the squared part, then it opens up or down. If y is the squared part, then it opens left or right. Okay? And I'm not sure, even if you did them, if this official 4P thing is the way that you see it, because there's different forms. So even if you did a whole lot of stuff in Algebra 2, you may have been looking more at the vertex form or a different form here, but this is standard form, and that 4P is going to be important to us. Okay, we're all good with that? So let's look at what's happening here. First of all, we're going to label these pictures right here. Here's what I want to label on this. We know that this here, this length here is P, okay, because that's labeled up there. And this length here is P, right? Same distance. That's your P. So whatever that number is in front of those parentheses, that's 4P. If you divide it by 4, that's the distance right there. Now, this length here, and use a straight edge for this stuff. You should have your ID on, so you should be able to just kind of plop it up there. And I'm going to do my best to get this line where it goes. See, I knew I was going to mess that up. It's hard for me to aim with this pen that's not always right. There we go. So I wanted to, that little orange line segment I just drew in should go through the focus and be parallel to the axis and the directrix. Is to just do your best to make it look like that's what it is. Okay. So this little orange line is important to us. It's going to help us get some points without having to do a T-chart, right? This orange section from the focus to the parabola, this length is, oh goodness. This length is 2P, and this length is 2P. So what's the whole length of the segment? 4P. Okay, so this whole segment here, it's called the focal segment, or focal chord rather, focal chord, or latus rectum. Okay. Focal chord or latus rectum. So those little distances are going to be important to us and help us graph all this stuff. Is this stuff sounding familiar or does it sound new? Familiar? Okay. All right, so now I want to make sure that we understand what that definition really meant about that whole equidistant thing. And this is the same picture, but we couldn't do it all in one picture because there's just way too much stuff. And I want you to do a perpendicular line from, let's see, we're going to do it. So here, you see if I'm at x equals 2, I'm not drawing it right here. I'm going to start at the parabola, but where x equals 2, down perpendicular to the directrix. So just do your best to actually hit 2 and your best to make it perpendicular, so it looks like that. Also do it when x is 1 and when x is -1. -1 should be a little bit easier because you can actually go through the, and then I'll get out of the way so you can see what I'm talking about. I want you to make these little perpendicular segments right there. Okay. Now, as I go farther and farther to the left, what's going to happen to my little green segments? They get longer and longer and longer, right? So now what I also want you to do is, with your straight edge, is to connect the focus. Let's label the focus. Let's see. This point right here is the focus, and it is always inside the curve. We're going to connect the focus to the points where it hit the parabola, like so. So that whole equidistant from a fixed line called the directrix and a fixed point not on the line called the focus, what that is saying is that the focus is in a place such that whatever, if this something hits here, this is congruent. These two are congruent. These two are congruent. And that's true for every single point going in either direction around the parabola. Okay? And that's where the application actually comes in real life for parabolas, which we'll look at here in just a minute, and that's an important thing. Because this distance is the same, but there's also like an angle of reflection and some other things that we'll look at here in just a minute. Let's label a few other little things. This point is vertex. Yeah, that was a hard question. What is this line here? Directrix, right? Which could be an axis, but not necessarily, right? Obviously, that's not one of the axes there. Everybody okay on all the parts and pieces of the parabola so far? All right. Now let's look at what happens with this. Now originally I had these two little charts next to these, but then it made everything too small. So we're going to have to kind of, you can see yours, I just can't show you both at the same time. And we're going to fill in both of these here. This one goes when the parabola opens up or down. Oops. And then this information goes when the parabola opens left or right. Some of it's exactly the same. So let's look first at what is exactly the same. Whether my parabola opens left or right or up or down, there's a couple of things that are exactly the same every single time, like the vertex. What the vertex is from that standard form is the same, regardless of whether or not it opens left or right or up or down. I get it from the equation the exact same way. So what is the vertex going to look like, you think? HK, just like the center was. Okay, so make sure you put it under the vertex a blank. HK. And you can put that in both of them. What is the length of the focal chord? Look at what we labeled in that first picture down at the bottom. It's 4p, right? Now, 4p, when you look at the standard form, it could be negative, right? That number, whatever 4p is, it could be a negative number. So can you have a negative length? No, technically no. Sometimes that ends up happening on graphs, but no. So how do I make it sure it's always positive? My answer, absolute value. So the focal chord is the absolute value of 4p. Make sure you don't think that those are ones, all right? So then the other things are different depending on which way it opens. Let's think about the axis of symmetry, okay? Axis of symmetry here, is this going to be an easy line to write the equation of? Yes, because it's a vertical line, right? And here it's a vertical line, here it's a horizontal line. So here it's an x or y equals, what is it? When it's vertical. X equals. This one is a y equals, right? So here, in general, x, my line would have to be x equals what? What would it have to show? What would this line, what x value, this line would have to share an x value with what? Right? Have to be h. So whatever h is, the axis of symmetry is x equals h. Here, the axis of symmetry would be what? Y equals k. All right, so you don't even have to be fancy and go figure anything out. For when it opens up or down, x equals h. When it opens left or right, it's y equals k. There's no figuring out of anything, right? So then let's look at the focus. We can look at this picture of mine. You can look up the one that's labeled, but we know that this is the vertex, right? And this right here is HK. Right? So this right here is HK. I'll go ahead and label mine. So if it's opening up or down like this picture right here, and I want the ordered pair for my focus, which is this point right here, which one of these two things does not change? H. My x value stays the same, right? It's the same as the vertex, but my y value changes by how much? P. So the ordered pair for the focus, x value is the same, but the y value, which was k, now has to be added to P to get my new value. That's why P is important to us. So if you understand how it works, it's not a matter of which one am I adding it to, am I adding or subtracting? Understand why you're doing it, and you won't get yourself as mixed up, okay? So let's talk about this. If it opens left or right, then what is that going to look like? H plus P, comma, K. And you can see that from up there. Now, the axis of symmetry is a line. Vertex is an ordered pair, obviously. Focus is an ordered pair. Directrix is a what? Is it an ordered pair or a line? It's a line, okay? And it's going to be right now either a horizontal or a vertical line, right? So if it opens up or down, is it going to be a horizontal or a vertical line? Horizontal. So I know it has to be a y equals something. So here's my directrix, right? This is the directrix. It is a y equals something. Well, I already know that if I'm right here, y equals k. So how do I get to this y value? Subtracting p. So y equals k minus p. K plus p gives you the ordered pair that is the focus. K minus p gives you the line that is the directrix. You see the difference there? So then, for when it opens left or right, your directrix has to be an x equals line, and x would have to equal what? H minus p. So you understand where those things are coming from and why? We all good with that? Okay, good. Any questions at all? All right, so this next part is very wordy. I didn't want you to have to fill anything in, but I really think this is a good way to make sure that you understand. Some of you may already get this, but I don't know that everybody does. So a parabolic dish or a parabolic reflector, we're going to look at both, is a curved surface with a cross-sectional shape of a parabola used to direct light or sound waves. So it has to say cross-sectional because technically these are 3D things, but the cross-sectional shape is a parabola. So when it's a 3D thing like a dish, it's called a paraboloid. That's the 3D version of a parabola. So here's a satellite dish, okay? I'm sure you've seen ginormous ones out somewhere, you know, or at least in movies. I mean, back in the day, if you wanted satellite TV, you had a ginormous one like this in your backyard. That, not so much anymore, but they still do exist, obviously, for other things. Well, there's a reason that they're shaped like that, and there's a reason that this part right here is there, even this, okay? Because here's your parabola, right? Here's the focus. It can work two different ways. These sound waves or waves of whatever are coming in when they hit the parabola. They're going to bounce back when they come in perpendicular like that. They bounce back and all hit the focus. So this right here is put at the focus. That literally focuses everything there to that point. Does that make sense to you? So these angles of reflection, which are all different, are all important. But that's why these little perpendicular things, and if I continued this down here, then those would all be, you know, perpendicular, and you'd get their directrix down here somewhere. That's not the directrix. But so it says any sound waves entering a parabolic dish parallel to the axis of symmetry. See how it's perpendicular to the directrix, but it's parallel to the axis of symmetry, and hitting the inner surface of the dish are reflected back to the focus. Every single one of them. Obviously, if it's parallel, there's all kinds of sound waves coming in, but that's why sometimes you got to turn it because you're not getting a good signal. You're trying to turn it so it's actually hitting it where it's parallel to that axis of symmetry. Radio telescope antennas and satellite dishes use this concept by placing a receiver at the focal point to obtain concentrated signal. So that's something coming in. That's something going out, which includes your headlights, but I couldn't bring in a headlight, same type of thing. Now, there are different types of reflectors and there's different types of lights, but a lot of headlights are parabolic in shape, or you might think of it more of a cone shape, but it's not really a cone. So in a similar manner, and I don't know how well this copied. I tried to make it where you could actually see what was going on, but it was a faded out picture to begin with. I couldn't find a better one. So this is my flashlight, and this kind of, you have to pretend like you're inside. So here's the bulb right here. The inside of this flashlight here, even the silver part that's reflecting, it's a paraboloid. It looks like this, and that's why. So the parabolic reflector in a flashlight concentrates the lights emitted by the bulb located at the focal point into a directed beam of light. This same principle is at work in your car's headlights and spotlights, where the sound waves are being received by the parabolic dish. The parabolic reflector in a flashlight is directing the light waves outward. So instead of coming in, now it's going out. The bulb is at the focus, so the bulb is, a light's going everywhere, but the light beams that are actually hitting here are reflecting back out, and they are all parallel to that axis of symmetry, and that's why you get the directed beam of light, and it's not really just going everywhere. Does that make sense to you? So there's your reasons why. And when I was looking for a better picture of this, I found this little project that was done in some science class. I don't know. But they made them make their own reflector to improve their Wi-Fi signal at the house. So like if you made like a paraboloid thing behind your Wi-Fi router, and any of the beams are like going, outside where you don't really want them or whatever, you can put that behind it and it bounces off and it should improve your signal. It was made out of cardboard and foil, so I don't know how much it helped, but it kind of got the idea across. But you can make your own reflector if you want. All right, so we're going to write the equation of a parabola in standard form. Then we're going to find all this stuff here. So I have it in this form. I want it in standard form, which means this is an it's an x squared, not a y squared. So is it going to open left or right or up or down? Okay, up or down, right? Because it's an x squared. So now when I go to figure this out here, we're going to do, and what am I going to have to do to get it into that form? What kind of stuff? Complete the square. So first we're just going to move it where all the x's are on the left. So we'll get x squared plus 10x, and I'm going to move the 16y and the 7 over. So that's equal to negative 16y plus 7. Everybody with me so far? Cody? So then I get x squared plus 10x. Then I've got to complete the square, so what do I put here? Plus 25 equals negative 16y plus 7, and then what? Plus 25, because you got to make sure you do it to both sides. Everybody with me so far? So this becomes x plus 5 squared equals negative 16y plus what? 32. Then what do I have to do? Is this in standard form? Look at your standard form. I got one more step. I got to factor this out, right? Because my coefficient in front of y inside those parentheses has to be 1. So this is going to be x plus 5 squared equals negative 16 times y, and then what? Plus 4 minus 4? Minus 2. Duh, 4. Don't ask me. Minus 2. All right, we good? So here's your standard form. Now, I need a few things in order to find all of that stuff. There's one letter that's very important to me. What is it? P. So I know that 4p in this case is equal to what? Negative 16. So what does p equal? Negative 4. Okay. So that's important to me there. Everybody good? All right. Now, as we do this, I'm going to probably write a little bit more in these boxes than you would necessarily have to. I want to make sure you understand where everything is coming from. So the orientation, meaning we already decided it was either up or down. So is it up or down? Which way does it open? Down. P's negative, right? You can't just look at this and decide what's happening, right? P is negative, so it's going to open down. We good? All right, so orientation is that it opens down. And that's because P equals negative 4. Our vertex, which we know is HK, at least on this one, let's write the extra stuff in here. You don't have to do that anymore. So what is the vertex here? Negative 5, 2. Okay. And then focus. So which one stays the same here? Is it X or Y? X. So this is H, comma, Y plus or minus P. Not Y, I'm sorry. K plus or minus P. Which one? Plus. K plus P, right? So in this case, it's going to be negative 5, comma, 2 plus a negative 4. So your actual focus is at negative 5, negative 2. And again, I don't necessarily expect you to write all that every single time, but I think at least once in your notes you need to have where it's actually coming from. So your axis of symmetry, all right, so this is opening down, which means is this an X equals or a Y equals line? X equals, right? X equals just H. So what is your line? Negative 5. X equals negative 5, because it's a line. So is your directrix a Y equals or an X equals line? Y. Okay, these two things are always going to be different because they're always going to be perpendicular to each other. So what you get is that Y equals K, is it plus or minus P? Minus P. So Y is equal to K, which is 2, minus a negative 4, right? So what does Y equal? 6. Everybody okay with that? Your focal chord length, that is the absolute value of 4P. Well, that means that's the absolute value of negative 16. What does that give you? 16. Can you find all of that stuff? Is any of that new from what you've done before? This is all one big fat review. Fantastic. Did you know about satellite dishes and flashlights? Yes or no? Some people know. Okay, so we at least learned something today. That's good. All right. So we're going to graph the following. Now, this is already in standard form, so that's good. Is this the form you're used to also? Or did you look at it in a different form? That's the form you did. Beautiful. So this should be all these ticks then. All right, so what's the vertex here? 3, 2. Up, down, left, or right? Down. What does P equal? Negative 2. Right? Your focus is going to be at what? 3, 0. Directrix, X equals or Y equals line? Y equals 4. Y'all agree with that? Okay. And then your axis of symmetry. So if the directrix is a Y equals, this has to be X equals. And it's X equals what? 3. Because with everything, you're using these two things right here. Right? You're using the vertex and P to figure these things out. And then your focal chord length is what? 8. All right, so let's come over here and plot some of this stuff. My vertex is at 3, 2. 3, 2. There you go. It's going to open down, so that's good to know. P is negative 2. Okay, my focus is important, so I'm going to go plot that. That's at 3, 0. Make sure you know which one's the focus and which one's your vertex. Then the directrix is at Y equals 4, and it's a line, so we're going to draw it in. You have to actually draw it in. And at this point, could you possibly see a mistake if you made one at this point, at this point in the process, rather? Because that pink point that I have there has to be halfway in between the green point and the green line, right? Because the directrix and the focus are the same distance away. This distance right here is P. Yes? All right. So then I can draw in, so I've got all of that stuff. My axis of symmetry is at X equals 3, so I can draw that in right there. Okay, so I've got those two lines. Those should always be perpendicular to each other. Annis, those should always be perpendicular to each other, right? What else can I draw in that's going to be helpful to me? The focal chord, right? So the focal chord length is 8. That means it is 4 on each side of this. So 1, 2, 3, 4. There's another point right there. 1, 2, 3, 4. There's another point right there. So I know which way it opens. I know where my vertex is. I know where 2 points on the parabola are. So I can get a general shape for my parabola that looks like, oh, something better than that. Oh, dang it. This pen just drives me nuts. There we go. Everybody okay with that? Any questions at all? Awesome. So you do the next one on your own. One of the points does go off the graph. So I know, but I knew that when I did that, I couldn't find another graph I liked. But it's just one off, so it's fine. Just don't want you to think you're doing it wrong when it happens. Okay, so this is a y squared, right? Since it's a y squared, it either opens left or right. And so here, you can rewrite this as y plus 5 squared equals 12 times x minus 0. You don't have to, but that's technically what's happening, so that your vertex is 0, negative 5. And since it's either left or right, since this is positive, that means it's going to open right. You take your 4p, which equals 12. That gets you p, which equals 3. Now, it can help to plot this stuff along the way. I can plot my vertex at 0, negative 5. 1, 2, 3. There's my vertex, right? So, and since I know already that it opens right, if p is 3, I got to go 1, 2, 3. There's my focus. And 1, 2, 3. There is my directrix right there. So understanding what the numbers mean and how that all works can help you get that. Then you can get it from this. That means that 3, negative 5 is my focus, and x equals negative 3 is my directrix. Has to be a vertical line. Axis of symmetry then also has to be here, which is y equals negative 5. So I can get it from the graph, or I can figure it out and then graph it. But those two things have to jive, right? And then my focal chord length is 12. That's going to help me get my actual shape here. So I don't go 12 from the focus. Make sure you're not going from the vertex. 1, 2, 3, 4, 5, 6. And then the 6th is like out here. So let's see if I can draw. It looks like it's lined up and then it's not. There we go. So once I have all of that, then you can get the general shape in there, which would look something like that, but probably better than mine. We good? It's not crazy hard, but pay attention to what's going on, right? Now, grab your assignment. We're going to fill in this definition at the top. It says focal definition. I'm not even sure, honestly, what that exactly means, because you don't need locus definition. You don't need 2 lines to define locus. So I don't know what's really supposed to go there, but that's where we'll write the definition for right now. And then, because I want you to actually write it down, and then I will just give it to you to put in your notes at some point. So here's what goes in these lines, which may take more than 2 lines for you, but I'll try and shorten it as much as I can. So a parabola is the locus, which is the set, of all points. PTS means points. We'll abbreviate a little bit too. In a plane, that in a plane part is important because that means it's 2-dimensional. Otherwise, it's a paraboloid. In a plane, equidistant from a fixed line, and then it says call the directrix. We'll just put it in the parentheses. That way it's less to write. It's still a lot to write, I know. And a fixed point, which is the focus. And then we're going to put that the focus is always inside the curve. So get all that done, and that's number 1 on your homework, because definitions are important. Words are important that you can muddle through yourself. A lot of times things sound really crazy and complicated, and it's just a parabola, right? And that's something else you need to realize. Just because you read it and it makes your brain hurt doesn't mean it's complicated. But all those words are necessary. We're going to work on parabolas again tomorrow, and then we'll move on to some stuff that isn't old news to you. Okay? We good? Anything else? Awesome. So you should be able to just be fantastic on this assignment.